The primary objective of crashing in CPM is to decrease cost, to increase cost, to decrease project duration, to optimize the path. The answer is to decrease project duration. The primary objective of crashing in CPM is to decrease project duration. And crashing is very important topic. Okay, so I have given some important points related to crashing concept. So crashing is needed for finishing the task before the estimated time. Okay, so the project completion time, we have to complete the task before the estimated time. The crashing is done. Okay, the cost associated with the crashing. Okay, so that is called crash cost. Because of crashing, direct cost increases, indirect cost decreases. Okay, indirect cost decreases because the project time decreases, right? Next question is, the effect of network compression is increase in the total cost, direct cost, indirect cost, overheads. The answer is direct cost. The effect of network compression is increase in the direct cost. Okay, so network compression is a crashing concept. Okay, the effect of network compression, direct cost increases, indirect cost decreases. Okay, so here the effect of network compression means crashing, the increases in the direct cost. That is the answer. Next question is, in time cost optimization of your project, crashing is done on all the activities lying on the critical path, only on activities lying on the original critical path and having flatter cost slope, on original critical activities and those that becomes critical at any stage of crashing in the order of ascending cost slope. The answer is on all activities lying on the critical path. In time cost optimization of a project, crashing is done on all the activities lying on the critical path. Next question is, the time below which the duration cannot be further reduced is known as normal time, crash time, optimistic time, standard time. The answer is crash time. The time below which the duration cannot be further reduced is known as normal time, crash time, optimistic time, standard time. The answer is crash time. Okay. This question also related to crashing concept. Okay, so the crashing is also called as contracting or compressing the network. Okay, so if you see this graph, you will get 2 more points. Okay, so the crash point, this one is the compression point, this one is the normal point. Okay, so normal time of the project, this one is normal time. If you compress the project, the compression of the project is maximum up to how much? That is the crash point. Okay, so that is called crash time. Okay, so in this, the normal point, that is the normal point have least direct cost and the crash point have high direct cost. Okay, so you can also calculate the cost slope. Okay, the cost slope is CC, that is crash cost minus normal cost divided by normal time minus crash time. Next question is, the direct cost of your project with respect to normal time is maximum, minimum, zero, infinite. The answer is B, minimum. The direct cost of a project with respect to normal time is minimum. Okay, so similar crashing concept, if you see this graph, the direct cost line is this one. Okay, so minimum direct cost is where the normal point. Okay, so that is the normal time gives the minimum direct cost, the crash time, that is crash point, gives maximum direct cost. Okay, So here they have asked with respect to normal time, so it is minimum. If respect to crash time, it is maximum. Okay. Next question is, updating may result in decrease in the project completion time, increase in project completion time, changes of critical path, all of this. The answer is all of this. Updating may result in decreases in project completion time, increases in project completion time, change of critical path. Some points related to network update is given here. It increases or decreases the project completion time. Change of critical path. Okay, so because of updation, there may be chances for change of critical path. For short duration project, updation is done frequently. Okay, for small duration projects, updation is done frequently. For long duration project, frequency of updation is decreased as the project is nearing completion. Okay. Next question is, the variance of the PERT critical path is equal to sum of the variance of activities lying on critical path, maximum sum of variance up to end event, minimum sum of variance up to end events, none of these. The answer is sum of variance of activities lying on critical path. The variance of the PERT critical path is equal to sum of variance of activities lying on critical path. So some important concept it is very useful for solving the problems. Okay, so if they have given variance, okay, so I am considering critical path, for example 1 to 3, 3 to 5, 5 to 6. So each variance is available, that is variance of 1 to 3, 3 to 5, 5 to 6, you just add it. Okay, so that is given here. The variance of PERT critical path is equal to sum of the variance of activity lying on the critical path. Okay, if they have given standard deviation, okay, so that is standard deviation is square root. Okay, so square and the square root. Okay, so this is the formula for standard deviation, this is the formula for variance. Okay, you can find the standard deviation by using the variance, that is square root of variance. Normal deviation formula is z equal to ts minus te divided by sigma. And also very important point is variance is directly proportional to uncertainty. Next question is, PERT requires single time estimate, double time estimates, triple time estimates, none of this. Okay, the answer is triple time estimates. PERT requires triple time estimates because PERT is event oriented, probabilistic in nature. It consists of 3 time estimates, that is T0, TP, TM, optimistic time, pessimistic time, and most likely time. The activity duration is beta distribution. Project duration is normally distributed. PERT is always preferred over critical path method. Okay, so the expected mean time TE equal to T0 plus 4TM plus TP divided by 6. So this formula is very useful for problem solvation. Okay, so PERT requires 3 time estimate, that is optimistic time, pessimistic time, and the most likely time. And next question is, in case the value of variance is more, then certainty is more, probability of certainty is more, uncertainty is more, none of the above. Okay, the answer is uncertainty is more. In case of the value of variance is more, then uncertainty is more. Okay, so because the variance is directly proportional to uncertainty. Okay, so if the variance is more, the uncertainty is also more. Next question is, in PERT analysis, the time estimates of activities and the probability of their occurrence follows normal distribution curve, Poisson distribution curve, binomial distribution curve, beta distribution curve. The answer is beta distribution curve. In PERT analysis, the time estimates of activity and the probability of their occurrence follows beta distribution curve. Okay, so that is the time estimates. Okay, so that is optimistic, pessimistic, and the mostly likely time, that is the activity duration follows beta distribution curve. Next question is, if an activity has its optimistic, most likely and pessimistic time as 2, 3 and 7 respectively, then its expected time and variance are respectively 3.5 and 5/6, 5 and 25 divided by 36, 3.5 and 25 divided by 36, 4 and 5 divided by 36. The answer is 3.5 and 25 divided by 36. The solution is given here. The expected time can be calculated by using this formula, that is T0 plus 4Tm plus Tp divided by 6. T0 is optimistic time, that is 2, most likely time given as 3 and the pessimistic time is 7. Okay, so you can find expected mean time, that is 3.5. Okay, so and variance, okay, so variance is the square of standard deviation. So standard deviation formula is Tp minus T0 divided by 6. Okay, so you just calculate the variance, you will get 25 divided by 36. Okay, 5 divided by 6 is standard deviation, 25 divided by 36 is variance. Okay, so here the option C is correct. Whenever an activity has 0 total float, then free float of an activity must be 0, but independent float need not be 0. Independent float must be 0, but free float need not be 0. Free float and independent float must be 0. Free float and independent float both need not be 0. The answer is free float and independent float must be 0. Whenever an activity has 0 total float, then free and independent float must be 0. Okay, so by seeing this, you can clearly understood that if the total float is 0, the independent and free float both must be 0. And the next question is, CPM has following time estimates, that is 1 time estimate, 2 time estimate, 3 time estimate, 4 time estimates. Okay, the answer is 1 time estimate. CPM has following time estimate, that is 1 time estimates. PERT is a 3 time estimates. Okay, so very important question, so don't mistake here. So 3 time estimates is PERT, 1 time estimate is critical path method, that is CPM. And next question is, time estimates of an activity in a PERT network are optimistic time 9 days, pessimistic time 21 days, most likely time 15 days. The approximate probability of completion of this activity in 13 days is 16%, 34%, 50%, 84%. Okay, the answer is 16%. Solution is given here. The normal deviation formula Z equal to Ts minus Te divided by sigma Te, that is expected mean time T0 plus 4Tm plus Tp divided by 6 equal to 15 days. Okay, so substitute all the values here, you will get 15 days. So find the sigma Tp minus T0 divided by 6, that is 21 minus 9 divided by 6, you will get 2, and normal deviation Z equal to 13 minus 15 divided by 2, you will get minus 1. Okay, so you have to remember this table. Okay, so if the normal deviation is minus 1, that is the probability of occurrences, that is 15.9%. Z equal to 0, 50%, Z equal to 1, 84.13%, Z equal to 2, 97.7%. So we have got Z equal to minus 1, so the probability is 15.9%, that is approximately 16%. And the last question is, negative float can occur in case of normal activity, in case of critical activity only, in case of subcritical activity only, in case of supercritical activity only. The answer is in case of supercritical activity only. Negative float can occur in case of supercritical activity only. Some important points are given here, that is supercritical activity. Okay, so it is negative float may occur and abnormal situation. Okay, and compression of the network. Okay, so because abnormal situation, so negative float means there is delay in the project, so it is abnormal situation. So what we have to do is we have to compress the network. Okay, so it increases the cost, that is direct cost of the project. Okay, so subcritical activity is positive float, normal situation. Okay, so it is ahead of the schedule, normal situation. A network has more than one subcritical path. Okay, so this is the points related to supercritical activities and subcritical activities. All the best. We'll see you soon in the next video.